Hey chemistry crew, Mr. Collier here, and in this notes we are going to talk about gases. So, gases are pretty interesting and we study them a little bit differently than we talk about solids and liquids. A common thing that people will sometimes forget is that gases do have mass. They are very low density, so we sometimes forget this. But a little activity you can do at home is to take, some sort of little stick, attach a balloon on either end, one that you've blown up and one that you haven't, and just, try to balance it. And what you're going to find is that the balloon that's blown up is going to tip the balance because they do have mass. So a full balloon is going to weigh more than an empty one. Another interesting thing about gases is that they can be compressed. So it's very easy to change the volume of a gas, and that's unique. Solids, liquids, they keep their volume, but gases are going to change volumes very easily. So we can put them into containers. We can make compressed gases. We can pump air into a bicycle tire, etc. And a part of this idea of gases changing their volume is that they're going to take up the entire container that you put them in. Liquids, as you transfer them from one container to another, they're going to change their shape, but they're going to keep their volume. But a gas is going to take up the volume of whatever container you put it in. So the amount of space between the particles that make up a gas can vary. They can be closer together or further apart, and that's just going to depend on what you put them in. Their particles are constantly in motion, so they're going to move through each other, which we call diffusion. And it's very easy to observe this. If you notice that a smell from a food will make its way through an entire room, that's because those gases are constantly in motion, moving around, bumping into each other. This is called diffusion again. So we can take a colored gas and put it into a container, and in just a few minutes, you can see it's going to spread out. This particular gas is bromine, which is actually an element. Now, these gases, because they are constantly in motion, are going to exert pressure. That pressure comes from the collision of the gas particles hitting the container that they are in. The amount of pressure that these gases exert is going to depend on the temperature. And so, generally speaking, if you have higher temperatures, those particles are moving faster, so they're colliding with more kinetic energy, and so you get higher pressures. Lower temperatures are going to have lower pressures. Now, all of these small gas particles have mass, and generally speaking, they're going to be molecules. The exception here would be the noble gases. So one thing that we talked about earlier in the year is this nomenclature of talking about a compound versus an element, but we also talked about the term molecule in there. So a molecule is just any two atoms that are bound together, whereas a compound needs to be different elements. So H2O, water, is a compound, and you can have a molecule of water. But like bromine is an element, but when you have two bromines that bond together, we call that a molecule. It's not a compound, but it is still a molecule. So molecule, again, just is any two atoms that are bonded together. They can be the same element or different element. Long story short, most gases are going to be molecules, atoms that are bonded together. We could have two atoms of the same element, like nitrogen, which is part of the Brinkelhoff elements, the 7 diatomic elements, or it could be something like carbon dioxide, which is two different elements making up a compound. And again, the only ones that don't are the noble gases, which will be gases, but they'll just be single atoms. Now, generally speaking, the particles in gases are separated by relatively large distances. They're pretty far apart. They tend to be moving in straight paths, and they change directions when they collide with something. And there is so much space between them that individual gas particles aren't really attracted to each other. So we've talked a lot this year about intermolecular forces and things like that. In gases, there essentially aren't really any intermolecular forces that are bonding them to each other. And that's why they spread out and take up space and move about kind of randomly. All right, we're loading here. This is not great. So when you have gas particles that are colliding, we say that they are colliding elastically, which means that they're not losing kinetic energy. So this would be an inelastic collision. When two things collide and they stick together, energy is lost. That's like any car accident is going to be an inelastic collision. An elastic collision is one where things bounce off each other and they don't lose any energy in that transfer. This perfect collision bouncing off, all of your energy is conserved. A close example to this would be like billiard balls when they hit each other and just bounce right off. Now, the interesting thing about elastic collisions losing no energy is that gas particles are constantly bumping into things, each other, the walls, etc. And if they were bouncing into each other and losing energy, we would see a resulting loss of temperature, because as they lose energy, they would also lose temperature. And the world is just not constantly getting colder, at least the gases in rooms are not. And so that's just one sort of everyday piece of evidence that these collisions that gases are going through are elastic. They're not losing any energy. So that elastic collision, again, is one of the ways we know that they're not losing energy, is the fact that we're not constantly losing temperature. We can put gas in a container and it's not going to just slow down and slow down and slow down until it becomes a solid and the particles are completely motionless. That's just not how the world works. So we've already talked about temperature several times this year as a measure of the average kinetic energy of particles, and that's also true for gases. The higher the temperature, the higher the kinetic energy. We also talked about how that means the higher the pressure as well. One of the things we're going to look at as this chapter continues is the relationship between those things mathematically, and that's been a big part of chemistry this year, is looking at the mathematical relationships between these chemicals. So we also talked about in an earlier slide how gas particles don't really exert any force on each other. There's no intermolecular forces. We basically assume it to be zero. There's no things, forces, intermolecular forces holding these gases together. So that's just a little introduction to gases, some of their general properties. That should have gotten you through page 1 in your notes. And now you can do pages 2 and 3 on your own. As always, let me know if you have any questions. Hope you have a good one.